Greetings. Hi. This is, if you're wondering if you're in the right class, this is MT155 Introduction to Solid Modeling, and it is probably one of the first classes that you've taken here at MVCC. It's in the first semester for the Mechanical Engineering Technology program, as well as the Computer-Aided Drafting and Design program, as well as a couple of others. So if you're supposed to be taking MT155 online, you are definitely in the right place. So just trying to show you guys here a little bit of the design that I was working on today for, well, this past summer for a local company. And just to let you know that this stuff is definitely useful. You're going to learn to do stuff like what I'm showing you here. And the neat thing about this is that I got this little side consulting engineering job through a student of mine. I helped him get a job at a company, and when they needed some engineering help, well, he told them that they should call me. So here I am, and showing you the results of what you may yourself enjoy the benefits of. So this is a cool little design of a linear actuator that pulls up on this link that pulls up on a much larger machine, and this is the structure supporting it with a threaded rod right here. And of course, this all links up nicely like this. And oh yeah, the linear actuator extends over here, so it's pretty cool. This is fun for me. So like I said, this is MT155 Introduction to Solid Modeling, and I'm Associate Professor Jeff Burt. You can call me Professor, you can call me Mr. Burt, you can call me Jeff. Just don't call me by my last name. That's all I ask. I might call you by your last name because sometimes we got 3 Daves in class, so sorry about that. But if you don't want me to, that's fine. Just let me know what you want me to call you, and I'll see if we can do some mutual respect. As you can tell, this is a virtual background because I'm in my basement, and behind me is a mess. And hopefully, yeah, maybe you'll see it someday. But and if you're wondering what this vision thing behind me is, it's a nice chair because I sit in my chair a lot. So yeah, here's my chair here. But behind me, as a virtual background, are the Grand Island bridges that go from Grand Island to the mainland. Out near Buffalo. So if you've ever driven to Niagara Falls, you've probably driven over these bridges. And I used to go under these bridges every day when I went to school as a kid, because this is where I grew up. And it's just a really nice picture, but it also shows, you know, beautiful structural elements. So there's a lot of engineering that goes on. So it's a combination of things. All right, so that's a little bit about me. Just let you know, I have a bachelor's in mechanical engineering, and I'm a professional engineer, and I have a master's in something or other as well. But so I do both education. I've been doing this for about 20 years, and I've been more than 20 years now, I guess. And I've been doing engineering work for a variety of different places and companies from since General Motors back in like 1990, something like that. So a bunch of different places since that time, and really, I enjoy doing the work that I do. So let me dive into not so much this course yet, but because it's one of the first courses you've taken here at the college, if not maybe the very first minute I'm talking to you here. Yeah, this light's kind of annoying. Let me see if I can change that. Oh, it's even more annoying. So I guess I'm going to stick with that. I wanted to let you know what MVCC has available. In fact, I find that sometimes students are in the wrong course because they wanted to do one thing, and it really turns out that they're in a program for something different. So right away, I want you to email me or call me, whatever it is, if you think you're in the wrong spot. Okay. Now, again, this course is usually taken by mechanical engineering technology students and computer-aided drafting students. And if you're in those programs, great, you know, you're definitely in the right spot. But you should also listen to what's coming next, because you can see what else is available and whether it's going to fit for you. And maybe you know somebody who didn't know that we had some pretty cool programs. So I'm going to switch over here to this. All right. Let's see if I can go to sharing, share screen, and there we go. All right, so here we are in on a whiteboard here. And so if I were in class, this is what I'd be doing. I'd be drawing this up for you. But at MV, we have about 4 different levels of programs. Certificates are 1-year programs. The point for a certificate is to get you out into the workforce with a few skills, and hopefully, you know, you can get a job. I will never guarantee anything, because no one can guarantee a job anywhere. But that's the point of a certificate. Get you some skills, get you out working as quickly as possible. We have certificate programs in like machining, welding, and CAD, which, you know, we might have some certificate folks in CAD. So machining, welding, CAD. Oh, a new cool one, newer, which is mechatronics. Okay, tronics. There we go. Yeah, this tablet doesn't do quite what I like it to for that. Okay, and so something like this, hopefully get you some skills, get you a job. All right. So now, next is AOS. That stands for Associate of Occupational Studies. Occupation, in other words, get you a job. And we have we've got a new program. I think it's called Metal Fabrication, and I think that's online now, if not coming in next year. So that is like a combination of these two guys, and it's a fabrication thing. We also have a CAD program and a couple others in the AOS. There's we can check the catalog, but other great things that are hands-on and so on for a 2-year program. Now, what does that do for you? Why should I take the 2-year program? Well, you're going to get more skills. Okay, so you'll be available for more jobs, but generally speaking, it's the same basic idea. Go out to a job, but since it's a 2-year degree, you also might be able to move up the ladder. So there's a little bit more, maybe more upward mobility, more skills. So, like I said, you know, between machining and welding, if you did both of those, then instead of just 2 1-year degrees or 2 1-year certificates, they kind of combine it together into a 2-year program. So you're just that much more in demand, shall we say. Okay, AAS is also, these are also 2-year programs because we're a 2-year school. But AAS stands for Associate of Applied Studies. And we have a number of these. So a lot of you are probably in mechanical engineering technology. That's great. We also have electrical engineering technology. We also have civil engineering technology. And there are a couple other 2-year AAS programs that that we're involved with here. And so what does this do? Okay, a lot of my students, they do this. They go get a job. Okay, a lot of my students get a job, but it's usually with a little bit more pay. A lot of these programs here, a lot of these jobs down here are usually just, okay, do this, do this, do this, you know, weld this, weld this, weld this kind of stuff. Not a lot of planning, not a lot of design going on, not a lot of, as much responsibility. I'm not saying they're not worth as much. You might even make more money doing some of these things, but in this case, usually it's it's usually a little bit more money or more creativity, more responsibility, more interesting stuff. Okay, now I know a lot of mechanical techs myself. Well, I wasn't a mechanical tech, but you know what? They started out as CAD drafters, okay? But when they start out as CAD drafters and they get some experience, then they move up the ladder, okay, because they have additional skills. And so the other thing an AAS person can do is they can go to a 4-year school. So SUNY Poly is one, but one of the best 4-year schools for engineering types is RIT. And so RIT, SUNY, and there's Buff State. Buff State has a program and that will get you, that you can transfer to and get your 4-year degree. I love RIT because they've got a great solid program. It's challenging, but they got so many cool things going on in campus with great clubs and activities, like, you know, the race car clubs and all those kind of things. And their 3D printing type stuff is phenomenal. They got all sorts of cool research going on there that you can get involved with. And that's why I'm always pushing for RIT. So you're going to have good grades. Guarantee it. You got to have good grades. And then what happens after that? After your 4-year degree? Well, then you can go off and get a job. All right. Now, most of you are probably, there may be none of you in the AS program, and the one that, you know, usually talking about here is the engineering science program. Now, this is effectively the first 2 years of an engineering program, engineering entry. These are technology, okay? What's the difference? The difference is for AAS, it's the big deal here is math. There's very little, if any, here at the certificate level. There's a little bit for the AOS. There's definitely a chunk more for the AAS. And if you go into engineering science, there's a lot more, okay? A lot more math, all right? And that's one of the major differences. It's a much stronger program, heavier duty. There's less, the AAS has a lot more hands-on. AS, the engineering science program, has a lot of math, a lot of physics, heavy duty chemistry, all that kind of stuff, much more head knowledge kind of stuff. And so what do you do with that? Well, you know what? Very few, if any, students go on to get a job. It is designed to be a transfer program. So you go on to your 4-year. Now we've got a great program that, you know, that works with Clarkson. And so a lot of students go on to Clarkson, but others go to RPI, Clarkson, etc. So, and then from there, some of them go on and get, guess what, a job, okay? And some places don't see a difference between a 4-year AAS and a 4-year engineer. So, you know, a place like ConMed, they're pretty cool with both most of the time. But this is much more likely to lead you to graduate school. Okay, so I know engineers that have become doctors or lawyers or PhDs in engineering, that kind of stuff. So beyond the 4-year degree. All right. And then finally, some folks ask me about becoming a professional engineer. All right. I'm a professional engineer, and I did not need a master's degree to do it. But let me tell you, it's going to be a whole lot easier coming from an AS program, a 4-year engineering science program, than from an AAS program. We can go into the details as why, but you can still do it. You can still become a PE after going through an AAS program, and it's a longer road. It's a little bit more difficult. You gotta, do a lot more studying because you didn't cover that stuff in your first 4 years, but it is still a thing. And you can't do consulting by yourself unless you have a PE. So that's why a lot of us go and do that. So this is the basic idea of what MVCC offers. And let's make a nice green for MVCC, mechanical oriented programs. All right. So you might say to yourself, hey, I thought I was going to become a real, quote unquote, real engineer, not this tech stuff, which is a little bit easier, not as much math, a lot more hands-on. I thought I was going to go to Clarkson. I wanted to go to RPI. Well, then maybe you are in the wrong program. However, if you're not that strong in math, you might be good, but it might not be very strong. Then it might make a whole lot of sense for you to do 1 year here and then transfer over to engineering science. This will serve as like a pre-engineering program for you. You'll get some good hands-on stuff. You'll get a little machining. All that stuff is really good, but you'll also bump up your analytical and your math skills and your science skills, stuff like that. And you'll be in better shape. So if there's some folks in your high school that you went to high school with that were like eggheads and they continued on, went on to like RPI, Clarkson, whatever it is, and you weren't as good at math, but you didn't really try that hard or whatever, and you want to just catch up to where they were, hey, the worst you can be is maybe a year behind. That might work out for you. Okay, so that is that's the lowdown on the MVCC mechanical oriented programs. I want to hear from you if you think you're in the wrong position. You could be in any of these particular programs, and if you said, oh, wait a minute, I'm doing CAD, but I really wanted to design a lot of stuff. Yeah, a CAD certificate or AOS is probably not going to allow you to do actual design work where you get to make a car or something like that. More than likely, you'll be given drawings or documentation to do from someone that's further up the food chain. Okay, not saying for sure, but I've worked in the industry and I know how it goes. Okay, so that's generally how that kind of thing works. All right, so I want to hear from you if you have any further questions or if you think you might be in the wrong position. There you go. All right, I'm going to hit pause on this for a second, and I'll get back to you with the rest of the intro video. All right, so I'm back and just switched over to the syllabus for the course. So this might be a little bit on the not so interesting side, but I need to go over this with you so you know how the course is laid out and what's expected of you. Now, I really wish we could be all together in the same room. There's nothing like having your faces and I don't know if you really want to see my face anyway, but you're getting it anyway. So, but what I want from everybody at some point in time in the first week is to contact me and let's set up a little one-on-one and we can just talk about stuff. And you're going to have some assignments as well. And, so that we can at least get to know each other. Hopefully, if you have any questions about me, you can do that. Hold on a sec. So let me just dive in here and just go pretty much line by line. I want you to send me questions on what you have, because I'm sure I'm not answering everything. And there's some things I don't have to do. So for example, since this is all online, be my guest, use your phone in class. Haha, all right. So there's that. But we're going to this is my name here, and make sure you don't misspell it because people do that all the time. Here's my office, but I never go there because I'm just teaching from home here. I'm going to be online during the COVID times. Here's my office phone, but if you leave a message, don't expect me to get back to you because I'm really not there and I'm not really grabbing my messages. But here is the first time I've put my personal phone on the outline here. You are welcome to call or text me. Just use it very, wisely. I'm might not be available all these hours, 10 a.m. to 10 p.m., but I try to make myself as available as possible because I know this has got to be so hard on you and on the whole learning process. And this is not, what anybody wanted to have happen, but here we are. And like I said, we're making the best of it. Okay, I even have a handle on Discord, and so sometimes that's that's better for students. Last semester, it worked out pretty well where we had some discussions on Discord. So if you get on Discord, there's a Discord app. I like it a lot, and I am in touch with a number of students on Discord, so it worked out pretty well. So that's a good way of getting a hold of me. And let's see, my office hours. I don't have anything official yet, and yet what really is important is what works for you, because I've had it before where I tell you what my office hours are, and it's not good for anybody, or at least not good for you. So by appointment works out a lot better. I'm just available, okay? Well, we're just going to see how it goes. But if you want something official, you can check Blackboard, and once in a while I'll have this is the official Zoom site for my office hours. So you can check to see if I'm actually up at that point in time with that online. So there you go. That's my office hours. And a great way to get in touch with me is via email. Because you have a record of it, I have a record of it. We know what time and date it was. Make sure you collect your thoughts a little bit. And I get it pretty regularly. All right, so that's how to get a hold of me. I just letting you know I'm going to be getting a hold of you via email. That's going to be the main way if I have to send something back and forth. And so you better be checking, and that is your MVCC email. So you better be checking that. I very rarely, unless there's something wrong with the MVCC email, I'm not going to be sending it to your Google or your Yahoo or your Hotmail account because it just doesn't. It's not secure, and many other things. So we're just going to stick with our MVCC stuff. And I am able to blast out an email from the Blackboard system to that. So this is how you get in touch with me, and that's how I'm going to mostly get in touch with you. Once in a while, if we're going back and forth on Discord, that's fine. If we need to text back and forth, that's fine too. All right, so here's the syllabus. And hopefully this is the right course that you're taking. And the course content, here's what the catalog says, and we are going to use three-dimensional solid modeling software. Notice how Solidworks, the program itself, is not actually included in the catalog description. That's because if we need to, we can bounce around to do something different if we wanted to. Solidworks is what I know best, but I did learn on Pro Engineer, and I've tried a few others as well. And we use Solidworks because it is the most used in the industry, so that you would have the best shot at landing a job doing something like that. All right, and so we'll go through more of what it entails in a second here. You're first going to learn how to create sketch cross sections. Using parametric construction techniques. Parametric means that you're using parameters. So if you want one thing to be twice as long as another, all you have to do is change one, and the other one's gonna change. That's an example of parametric construction techniques. Then we're going to learn basic solid modeling features: protrusions or extrusions, bosses, cuts, rounds, blends, revolves, sweeps, all sorts of cool things, basic fillets or chamfers, and I'll be able to show you that in some videos coming up. All right. So planning is really important when you're talking about these parametric. It's not just sketch something and boom, there it is. We need to think about it and plan ahead. Often I will sit at my desk staring at my screen for minutes or sometimes on the order of an hour or two before I even really start a project, because I want to think ahead of time how I want this to go, so that it's so I am capturing my design intent. How do I intend for this to actually be? So do I want something 6 inches and something else 12 inches? Or do I really want this half of whatever that is? Or that twice whatever the other thing is? That's what I mean by design intent. That's a very simple example. And these programs are very powerful and can capture a lot of that kind of design intent. Okay, so then we're going to put these parts together and make assemblies of them. And then we're going to make drawings. So 2D drawings are still used in industry. We still need to know how to do them. They still tell a lot of information ahead of time, so to actually make the stuff. So it's not as easy as just putting a pretty picture together. There's a lot of thinking involved, a lot of understanding of what information is needed, because it's all about communication. So then we also have spreadsheets. Spreadsheets are an important part. We won't use word processing very much, but spreadsheets are a very important part of them. In fact, spreadsheets are, I would argue, sometimes more important than computer-aided design. But we're going to use spreadsheets and show how they get integrated into a CAD model. All right, so that is the outline here, and these course topics. This is a lot more detailed about what I was just describing, and you'll see soon enough. Hey, I got to change it. There's a line missing. There we go. All right. And all right, so materials required. This might be a stopping point for some of you. But already, if you're watching this, you have a computer. The question is whether it's going to be right. Well, first off, 6-inch calipers, accurate to, this is the bugger here. You want accurate to 1/1000th of an inch, okay? You can get some cheap ones that are accurate to 100th of an inch, but you need to get one that's open to a 1000th of an inch. So I put these up here for at Harbor Freight. You can go pick them up right now over at Harbor Freight. Sometimes they've got a coupon. They're $20. I was able to, a couple of years ago, get some from Amazon for $10 a piece. I looked for some and I can't find any right now. So you can get these very same ones for around $20 and on Amazon. Do you need them right away? No, but should you have a set of these as a mechanical engineer or a CAD technician or anything like that? Yes, you should have your very own. Now, I'm also going to warn against buying something really, really nice, because those have a tendency to grow legs and walk away. So anyway, let's see if I've got some right here. I do. In fact, somebody did leave these in the, okay, how does this work? Here we go. Someone left these in the classroom, and I asked around, and nobody wanted. Now these are dial calipers. So as you can see, they have a dial on them, and they're different to read. It takes a little bit more skill to read these than it does the digital ones. But this is a really nice set, and I keep them within arm's reach because that's what we do. And so you should have your own set. Again, when you consider what textbooks cost and what other people, what welding costs, to ask $20 for a set of calipers that you're going to use is probably not a big, it's not a big ask. Let's put it that way. So definitely go get these, and you'll use them much more towards the end of the semester, but get them sooner rather than later. Okay, so another thing is the big thing. Internet-connected Windows 10 computers capable of running the Solidworks software. Now, on the one hand, you could go to a web page and say, Solidworks computer requirements, right? What you're going to end up with is, something from Solidworks that says, all right, first off, Windows 10 Okay, so we're going to be running SolidWorks 2019, 2020, something like that. Oh, EDU 2020, 2021. And you're going to want Windows 10 and Windows 7 at the very, but hopefully not. That's Windows 7 was a great operating system, but it's reached the end of its life. Okay, you're going to say 3.3 RAM, 16 gigs. They're probably right. You could probably run it on something that's 8 gigabytes, but it's going to be slower than a dog and be bad. Okay, graphics cards, certified cards and drivers. Okay, you know what? This is what they tell you when, so that they know it's going to run all the things. Guess what? This is an introductory course. You do not need all the things. Okay, so you should have Excel. I hate to say it, we're going to be using Excel, and you should have Excel. But luckily, you're a student, and you can get Excel on your computer for a relatively low amount of money. So pretty cheap for a student thing. So you should, of course, have antivirus. And don't worry about these things, because these are different programs. This is SolidWorks products right here. Okay, now I have seen SolidWorks run on some pretty cheap computers. When I mean cheap, I mean around the $500 range, but don't use that as your benchmark. So I've got some benchmarks here for you. Okay, they said 3.3 gigahertz. I'm recommending an Intel i7. i9s are way too pricey. You do not need an i9 unless you're a gamer. If you're a gamer that needs an i9, then you spend too much time gaming, that's for sure. So an Intel i7 should be fine. An i5 should probably work. I would not use an i3, and definitely not a Chromebook. Okay, Chromebooks will not work, period. They are not running Windows 7. They are running Chrome. So you have to have, sorry, not Windows 7, Windows 10. You need to have something that's running Windows 10. 16 gigs of RAM should work. Okay, good. That's what I'm running on my computer here, and I'm running some pretty heavier duty stuff than we're going to be dealing with in this class. 8 gigs of RAM might work. I don't know if you want to gamble, but there you go. 8 gigs of RAM might work. 4 gigs of RAM will not work. We tried that last year. It will not work. Okay, I had a student that just got a cheap computer, 4 gigs of RAM, wouldn't install. He just upgraded the RAM to 8 gigs, and it installed. Didn't run very well, but it installed. So there you go. I would recommend a dedicated video graphics card. Now, most cheap computers have an integrated, it's part of the motherboard graphics situation. In fact, that can still work. It won't work great, and your pictures, you know, your video or your graphics might not look all that hot. But you know what? It's an intro course, so it's not that big of a deal. But if you have a dedicated video graphics card with like 2 gigs of memory, usually something like that, then you should be fine. It might not run all the things, but it'll be okay. People say, what brand do you buy? I buy Dells, not because they're the best in the world, but because they have a good place on their business refurbished. So the used ones are ones that often just returned. I bought, no, it just has this one Dell here. Oh, I bought it for, I think my mom, something like that. Bought it and had done pretty well. What you do not want is you do not want something cheap, because all of these folks make good computers and they make cheap computers. The way they make cheap computers is by cheaping out on the components. Okay, so the cheaper they can make the components, that's how they get cheap computers. So I'm not saying you have to spend an enormous amount, but one thing I would definitely avoid is shopping at Walmart. Walmart, that's how they get such cheap computers with good specifications, is because they just have the cheapest components and they might overheat. That happened to us once. We had a computer from Walmart that fried because it just didn't have good heat distribution, and so it eventually overheated and died. That was unfortunate. If you happen to have the money, number one thing I would say after getting something that works pretty well is screen size. I have a 17-inch laptop over here, and I'm looking right now at a 32-inch monitor. I mean, granted, I use this all the time, and I've got old eyes, so the big monitor really helps out. And the more screen size you can get, the better. Real estate is king. And I bought a 21-inch monitor back in 1999, and it was like $900. And I didn't think it was a bad investment. It was one of the biggest at the time, and it was big and heavy and stuff. But it was still. Real estate is king, and you need to and you got to take care of your eyes as well. So I would definitely go with, especially if you can get it, a relatively low cost large monitor. You don't need the biggest and the baddest. You need something well, maybe biggest, but you don't need something that's really expensive. Just a decent sized monitor that's bigger, especially if you got a small monitor. If you got like a 15 or 16-inch laptop, something like that, get a monitor to go with it. You will thank me. Couple $100 should be fine. Okay, so next thing, hey, can I use my Mac? The answer to that is yes, you can. However, you have to learn how to make your Mac run Windows. Macs do run Windows. I do not know how to make them do that. My son does, and he can maybe give you some pointers on that if he's going to be helping out with this class this semester. He might be a tutor. But beyond that, all I know is that you need to dual boot it or use something called Parallels. So you're going to have to look up Parallels for Mac. I think it's a $50 thing. On top of that, you're going to have to buy Windows to install on top of Macs. And then on top of that, you'll have to install the Solidworks stuff. Okay, that being said, you need to have internet audio and video communication capabilities. In other words, I still will want to converse back and forth in real time with you doing Zoom or whatever. This now should probably be a given considering the state of the world. But there you go. So as you can see, I've got headphones. You do not need to have something fancy like I have. I've just been able to invest in this stuff because this is what I do for a living. You can have your basic, if worst comes to worst, your basic cell phone with speakerphone can work. But the better setup you have, the less issues you'll have with background noise or small screens or whatever. Okay. So I do not have a textbook assigned for the course, but I do have a suggested, if you're the kind of person that likes to learn from a book, here you go. Blanchard and Blanchard do a pretty good job with it, but we are not going to follow the book. We are not going to do anything with the book. This is just over and above anything. So maybe if you've got an employer that said, hey, we'll pay for the books, hey, have them pay for this book, and if you like it, then you like it. Let me know how you think, what you think of it. Okay, whew. Grading scheme. All right, so let's start with the A's, because this is where most people actually kick in this course. A lot of people do quite well in the course, and that's because that's the way I set it up. We'll talk about that in a bit. But that means that you clearly mastered everything that we discussed. A B is not bad. It is that you demonstrated some mastery. You really you nailed a lot of things. All right. C is definitely on the next rung down. You got some basic. You know how to click here and click there, and make some things happen. A D is that you had a clue. All right. One time I had a student who was wondering why he got a D, and he argued that he had a clue. But I had a clue, and I said, yep, that's what a D means. Okay, so you get it. That's what you earn there. And anything below that is that you really didn't get it. Okay. What really happens? How do people fail this course? Is that they do not keep up with the work. Period. You know, they get lazy. They say, oh, I'll do that next week. Nope. That's how you fail, simply by assuming you do it next week, and then things snowball and bad things happen. So what's going on here? Uh-oh, I've got a big blank page here. I think there we go. All right. By the way, the link to this file is going to be made available so that you can just click on it. You can always refer to it. So I'm not going to hand out anything in paper or whatever. So you can always refer to this. All right. So some of this might change over time, but I think this is going to work out pretty well. Oh, I think I missed, I haven't put in a couple of these dates, but this should be about right anyway. All right, so I've got a survey that's going to be in the Blackboard assignments. You'll see that, we'll talk about that in a second, and a math quiz, and then some reading that's going to go on. And those are relatively quick, straightforward kind of things. The math quiz is going to be done in a team fashion. So we'll see how that goes. If you're wondering, what, math, what? Okay, no, I'm going to put you guys together in teams and you'll learn a few things here and there. All right, and then we'll talk about design intent and how the course moves forward. And then we're going to get into the meat of it. All right, so starting off on the SAW project. So these things should be done within like the first day. The first day is August 31st. But so you effectively have a week to do these, but you don't want to take a whole week to do these very basic things. You want to get right onto the SAW project. So this is the due date, by the way. This is not the start date. This is the due date. So I usually give you a little bit more time than you probably need. Some of these are a little bit more aggressive, but now we have a SAW project where you model up a saw. And I take you through it step by step, and then you have a checklist to go through, and then when you're ready, you hand it in, but then we go over it, and you might have to redo some things. So I'll go over those checklists in a little bit and how that works. But then we make a screwdriver, which is a little bit more complicated than the saw. Then you're going to be put into teams after the screwdriver, and you're going to get together a project for the end of the semester. And this is going to let you think about how that project is going to go forward. And we'll talk about that in a second. Then there's the Crescent Wrench. The Crescent Wrench is the most interesting. It's most complicated, but it's the most fun in my book. Screwdriver is really where the rubber meets the road. This is a cute introduction to the saw. Screwdriver, a lot thrown at you, okay? The Crescent Wrench, that's a lot more fun. Then we put them all together into tool assembly. That's easy. The pegboard hook, it's just because I needed to throw a couple extra things at you, and we put that on there. And there's some neat skills that are shown here, but not a whole lot. And then we go into spreadsheets, okay? And spreadsheets are tied into design tables. There's a Solidworks design table tutorial. Do not ask me about how to do design tables. I do know, but you should have that as if you go through the design table, it'll show you basically. And when I ask you to do a design table in your project, it's really not that difficult. And students skip it all the time, and they lose a lot of points for it, which is unfortunate. I don't know why, but it is, once you go through this tutorial, they're pretty straightforward, and I don't ask a whole lot to be put into the project. So then there's the spreadsheets, and I'm still wondering about this mug project. This mug project is really good, but sometimes we run out of time, and we'll see how that goes. But all it is design a mug, and we'll see how it goes from there. Some people struggle with this because they're like, wait, what? what am I supposed to do? I said, design the mug, draw it up yourself, do it all yourself. I don't have any videos for it. There are no videos for the mug project. And then there's the major project and presentation, which I'll I guess I'm going to go over that now. Okay, so like I said, these things could be done on one day. Saw projects should be able to be done in maybe a couple weeks. Some do it in, I have students that do it in a day, and other students that might take them a couple weeks. If you are stretching it out to 3 weeks, then you are going a little, we need to talk, okay? In fact, if you're really struggling with it early, I want to talk to you early, okay? I don't want this, halfway through the semester and you're not done the SAW project yet because you're thinking that it's not important. That, oh, by the way, go at your own pace means go at your own pace faster if it's faster than the schedule here. It does not mean dilly-dally, and if you get the SAW done by the end of the semester and you do it well, you get an A. That's not what it means. I had some students last semester who said, oh, well, he didn't tell me anything. It's like, no, the schedule's right here. I'm not gonna remind you every day. It's right here. So if you have questions on how to do stuff, I'm here. I'm totally all over it, but I'm not gonna sit here and tell you and every week. Now get your stuff done. I mean, I might, but this is what I mean by that. So, all right. All right, so that's the SAW project, screwdriver, and so on. The mug project, like I said, is just about drawing your, modeling up your own mug. And here's the major project and presentation. I guess I don't have anything more on that. Major project and presentation. What it is you pick out something in the real world and you model it up. That's where those calipers come from. You have to measure it and figure out where everything is, and then you model it up. And it's got to have, you're doing this as a team, and it's got to have at least 6 parts. You're going to have assembly and a sub-assembly and a couple of drawings to go along with it. And you're going to need to make it a design table with it. Don't take notes on what I just said. I have a whole list with a rubric of exactly what is expected for that. And you're expected to use a bunch of different things, a bunch of different techniques. So if you only use one technique, then you're just showing me that you only learned one technique. I want you to show me what you learned and prove to me that you know how to use it. And also, it's a great situation. I had a couple students that were doing, that were put together for this presentation, this project thing. And they did such a good job, and they got done a little bit early. They were able to 3D print it in our 3D printing stuff area. And a year and a half later, they're looking for jobs, right? And one gal, she got an interview someplace, and she was kind of nervous and didn't know what to do. I said, you know what's great? Get a prop. And she was like, well, what do you mean? I said, what about that project you did for solid modeling? Bring it with you to the interview. She's like, oh yeah. Guess what? Her partner did the same thing. She just, gave it over to her partner, and she used it. By the way, these gals, they both got job offers. I mean, granted, they're really, really top students, but they both got job offers, which is great. And I think they're both working at the same at their respective spots right now, and they're doing very well. But that's the kind of thing you want to do. You want to make it something that you're proud of. So how do you get to that point? You work really hard all the way through this to get as much time to do the major project and presentation as possible. Also, you got to work really hard to learn all those things. Now, when I mean work hard to get through it, I don't mean rush, because students try to do cut corners and say, I don't need to watch that video or whatever. No, that's not the way to do it. The way to do it is watch the video carefully so you don't have to go back because you made mistakes. And that's what I'm trying to say here. The course is intended to be mostly self-directed. You can work as far ahead as you desire. And but I'm not going to grade your crescent wrench if you haven't finished with the saw. Okay. Now you can work ahead, but if I haven't been able to get to it or whatever, it's not going to be graded yet. So I had students who just wanted to try to skip the saw, and they'll take a 0 for it. It's only worth 10%, right? I said, well, you're going to get a 0 for everything because I'm not going to grade anything beyond what you've already done. The point is that you learn stuff here that you're going to apply further and further and further. If you can't figure it out here, you're definitely not going to get it later. Okay. So I have a whole bunch of videos online. So we're going to talk about Blackboard here. And in a second, I go back to the grading bit. All right. So here's what happens when you feel that you're done with the project, including all the Blackboard assignments and so on and so forth. You email the assignment in. Then I'm going to look at it with you, okay, in real time at the same time. So effectively an office hour kind of thing. It'll only take a few minutes. Saw probably 5 minutes, and maybe 10 minutes for the other ones, something like that. And if everything is great, then you get 100%. All right, you've earned it. You've earned that 100%. If you have any errors, if I have to send you back, then the next review costs you 5%. Okay, and then if you've got any errors after that, it costs you another 5%. So you start with 100. If you're doing perfectly, great. Then you're going to bump down to a 95, and then maybe a 90. Now, then and you only get 3. You only get 3 reviews, because by that time, you're just not listening, or I don't know. We should have a talk if you can't get it after 3 times, because there's a lot of helps to go on there. Now, here's the other thing. Here are the due dates. If it is later than this date that you actually finish, not when you turn it in the first time, but when you actually finish, then your grade drops by another 5%. So you have to do it right, and you have to do it on time. Okay, so you got both of those issues, but that should not be surprising. All right. So unfortunately, we're completely online. I'm used to doing this at least part-time in class, and so this is going to be more challenging. I get it. But at the same time, you're gonna learn stuff, and you're gonna learn it. There's value in the struggle, so we'll go from there. Now let's look at what the Blackboard system looks like. Oh, edit mode is on. Here's what you're gonna see. Okay, so here is fall 2020. Oops, wrong one. There we go. Fall 2020 MT155. And we start with introductions. And here you have a classroom arrangement. I'm going to have to go through some of these things and edit it for the online version. Probably take a couple things out. Then you're going to have a computer skills survey. So you're going to go through that and use the NVCC email account, start an email, and copy and paste this stuff in there, okay? And then answer them, all right? Send the email here. And you can even do that now if you want to. Not a problem. As long as you can access your email and Blackboard. All right, then I describe what design intent means. Remember that phrase, design intent? It actually came up in work today when I was talking to my former student, and one of the guys he worked with, and the guy he's worked with said design intent. I hadn't even mentioned it, but here it comes, design intent. So, so I got a couple things on design intent, and then there's an article and a comparison of 2D and 3D CAD, and then some download and installation instructions for Solidworks. And I'm going to update all that stuff for you as soon as I get the codes. So it should be updated pretty soon. All right, so then we go into the level 1 project. And I'll just go into here. Here's a basic introductory tour. So I do a quick video. So if you just click on this, another thing comes up, and here we go. Okay, for some weird reason, it's got this going on here. So each one of these that has a link has a video, and here we go. I don't think you're getting the audio on this, and I'm hoping you don't, because it's pretty boring, because it's just me talking some more. Now, some of these videos are done a while ago, so the interface looks a little bit different, but it's still definitely applicable. And I go through the basic making of a part, and I show you the different parts of the screen for SolidWorks and what's used for what. And watch out for this. You know, these things, they show you important information, and just go through that kind of stuff. So each one of these links here opens up to a video. All right. Okay, this one doesn't even have an ad on it. And I use this. This is the very first video. It's 37 minutes. If you go through it carefully, you'll be done with the first project in, well, you'll probably have to pause it, so just double the time. You'll be done, not with the first project, but with the first part in an hour and a half, maybe less. So just go through it. Some people try to speed it up, but you know what happens? They miss stuff. And then they say, oh, I missed that, you know. And especially now that you're not in class, you don't have the opportunity to raise your hand. So just go through it at the right pace, and hopefully you know, and a lot less likely that you're going to miss something. All right, so I also have, make sure you watch this video, because students, you know, they don't look at these additional things. I can't tell you how many times I've had students say, how did you get this thing to line up, blah, blah, blah. I said, right here, look, at 23 minutes of the video, you show how to line it up. They don't read this stuff, especially not being in class. I have a wealth of information. I've used these videos for years, and when I get 10 of the same questions, I say, boy, I must not have covered that. So then I put a little additional hint right here, and people miss this one too, okay? So make sure you go through the hints and so on here, and then when you're done with that, we will go to, is this it? Okay. That's not it. Ha, found it. Okay, so here I have checklists, and I'm going to make this available to you as well. So the checklist is going to go on down the list. Now, I'm assuming that you did this one. You followed the video carefully. Some students think that that's all you need to do. Yes, the vast majority of information is in the video, but there's still some things that, like I showed you, I missed something somewhere. Make sure you go to that, go to the assignment. So, and these are some of the key things that people forget, or they don't notice, or whatever. So I'm going through the checklist here, and for your own self, you can go ahead and make sure you did all of these things. When you're done with this checklist for this whole project, okay, so we've got a rivet here, we've got a blade here, a handle here, and then a rivet drawing, and then they all go into this assembly. So I give you lots and lots of hints and information about how to do these things right. Which brings me to this point. If you think that you've had some CAD experience, if you think you learned some stuff in high school or maybe an internship somewhere, that's great. And I think that's a wonderful start. But do these projects the way I show you. If you think you're going to do them your way and impress me, the chances of that are very slim. I have had some students that actually say, hey, what if we did it this way? I was like, hey, that makes sense. But that's extremely rare. And so just save that for a different time, or maybe office hours, and say, hey, could we do this way? And I'll be like, yeah, let's talk about that. But there's a I've set these things up very particular ways to teach you very particular things. So if you want to waste your time, go do it your way. If you want to move through and learn something and earn a good grade, then do it my way. Okay? Appreciate that. It's kind of like saying, hey, English teacher, I think we should spell these words this way and create sentences that way. You wouldn't say that to your English teacher, would you? I don't think so. Okay. So I'm making up these, I'm going to make up these project checklists, and you go through the checklist. Then when you're done with those checklists and you've got everything ready to go, you send it in to me, and we'll be, and then we can have a discussion. All right, so that is almost where we're done with here. So all assignments are given in the Blackboard system and through Google Docs. All right, so I'm going to be sending you that out. So you should get a Google account if you don't already, and so that you can access some of those documents. All right, so it is your responsibility. I wish I could help you out more. But make sure that your technology access schedule and other resources are adequate for timely completion of all assignments. Can't tell you how many times I've had students say, oh yeah, I got a computer, but then it doesn't work. And then they're struggling 3 weeks into the class. You need to have this stuff ready the first day of class, okay? I hate to say it, that's all I can do. And so the MVCC's IT department can help. You might be able to bring a computer in. And so on, but this is where we're at. This is what we've got. So not having a computer that can do the work or the software or whatever 4 weeks into the class, that's not an excuse. I wish I could say something different, but we've got to. I've got to move people through the course, and we have a date at the end of the semester. It's not like you can squish it all into a week. So anyway, make sure that this is happening, and if it's not, tell me ahead of time, and maybe we can work something out, or at least I can get you resources to get you moving faster, but don't let it sit. All right. As it goes to plagiarism, I've seen a lot of it. Don't let me catch you. I will hunt you to the ends of the earth and make sure that you never do that in an MVCC class again. So I would much rather you say, listen, I just was not able to understand this. I wasn't able to get it done. My cat died. I don't know, whatever it is. Much rather hear that from you than find that you took somebody else's work and claimed it as your own. All right. Don't go there. Just don't, because I get very angry. It wastes my time. It wastes your time. And then it makes me think, oh, look, so-and-so's a cheat. That's what I have in my head. You don't want that. I don't want that. I want everybody to be known as a hard worker, even in difficult circumstances. Okay. So I also employ a system that checks for original work. Like I said, the software is very complex. It leaves fingerprints in a lot of different ways, a lot of different places, and I know how to look for it. If, let's put it this way, it's going to be a whole lot easier for you to learn this stuff than it is for you to plagiarize this stuff. Trust me on that, because it's going to take a lot of work for you to find all the digital fingerprints and change them, if they're even possible to be changed. Okay. If you happen to have a disability, I'd like to hear from you, but we can talk about that later. And then civility statement, if you happen to be talking to anybody in class or myself, keep it civil. We can have disagreements, that's fine. But let's try to, not try, we are going to keep it civil, and we want everybody to feel that their voice is heard and recognized and valued. and no one should be discriminated based on sex or any other kind of garbage like that, or violence. Any of that kind of stuff is completely inappropriate for this kind of situation, and pretty much for any kind of situation. So no discrimination based on that is going to be tolerated. Okay, I think that's about it. So I had to say some of those things, and those are the policies of the school, policies of this course. And I'm sorry that this took so long, but that's usually what we do the first day of class anyway. But now you've got your marching orders, you know, to go to the Blackboard system, but also I'm going to be setting up those assignments a little bit better, so it's a little bit easier to understand, and I'm going to be setting up some teams. And so pay attention to your email, pay attention to the videos, and all of your assignments, and make sure you get in touch with me, and let's meet, like at least Zoom wise, let's meet, and we can, and because I'd like to get to know all of you. All right, have a good day, and I hope to hear from you very, very soon.